So hello everyone, myself Haziq Kirmani, and this is our first question from Kinematics in our most expected archive series, and this is one of the most famous questions in kinematics, and you have seen it at different places, I'm sure for that. And let's try to solve this. It is from the concept of relative motion, and it becomes really difficult if you are not visualizing things properly. So let me tell you how to do this. So we have been given two airplanes, A and B are flying at constant velocity, nice, in the same plane, okay. So both of them can be drawn on this paper, fine, 60 degrees and 30 degrees. Okay, let's draw it first. Suppose this is our horizontal plane, and suppose this is our A, and this is got to be our B, fine, this is our B, fine, and this is 30 degrees while this is 60 degrees. It says the speed of A is 100 root 3. What is the speed of A? 100 root 3 meters per second, fine, at time equal to 0 seconds. So initially observer in A finds B at a distance of 500. Okay, suppose A is here, so at t equal to 0 I'm saying, and B was here for example, okay, initially. So this distance was 500, fine, that distance is 500, nice. And it is given that the observer sees B moving with a constant velocity perpendicular to the line of motion of A. So there is a person in A, flight A, that guy sees this plane B moving perpendicular to the motion of A. So for a person in flight A, for him the motion of B is perpendicular towards A, fine, okay. So that means the velocity of A, that is in the direction of a line that is parallel to the motion of A, they should be equal, isn't that? For example, if a car is going 100 meter per second, one more car is going same velocity 100 meter per second, we'll say for both of these cars they'll find the other car to be at rest. Why? Because they have same velocity in same direction. What if this car had an upward velocity also? A person in this car would say the other car is coming perpendicular towards the other car, isn't that? Because at this point both will be here, but the second car would have come closer. So a person that was in this upper car, he would feel that the other car is coming towards him, isn't that? So can we conclude, okay, this was 30 degrees, if this line is parallel, so this is also 30, so this should also be 30 because total is 60, isn't that? Can we say velocity of B in this component, that is B cos 30, that should be equivalent to the velocity of A, that is 100 root 3. So from here we get velocity of B to be 200 meters per second. Now since we got velocity of B with respect to the ground, what is asked? A just escapes being hit by B, T naught is that seconds, find T naught basically. So what was the distance between them? Initially 500 meter you will say, and what velocity of this B is used in traveling perpendicular distance? You will say, sir, that is VB sine 30, isn't that? This is your VB, look again, this is your VB, this component should be equal to the velocity of A. What about this component that is trying to cross the river in other analogy, isn't that? This velocity sine component is trying to cross the river, basically trying to hit the plane A. So you will say, sir, VB sine 30 is distance by time. From here you will get time, I'll write it here, time is equivalent to 500 divided by 100, 200, 1 by 2 is 100, so your time is 5 seconds. I hope you got the proper visualization of this problem, and I hope you subscribe for upcoming archive series. So thank you so much for watching this video, best of luck.